Hi all, and welcome back to our ggplot book club. Today we are taking on what's currently chapter 19 of the ggplot book, where we'll be talking about the internals of ggplot2. Some of the learning objectives in front of us include what is the difference between user-facing code and internal code? What is the distinction between ggplot build and ggplot gtable? What is the division of labor between ggplot and grid? And finally, what is the basic structure or motivation for ggproto? Before I forget, I want to thank the previous cohorts. Most of the slides here that I'm presenting today are their work. What I've done for the most part is change up some of the navigation, such as what you see in the table of contents to the left, so that future cohorts could perhaps more easily literally navigate through these materials. When we think about the libraries that we'll be using, the ggplot, of course, some of the others that you've seen, but in particular, we're talking about ggtrace today, which those in the data science community, in the R programmer community, greatly know about the work of Jun Cho and their work in trying to understand what's really going on here in ggplot. I would also want to point out that at the time of this video, this chapter ggplot2 was labeled as a work in progress. Nevertheless, there are some great materials here. But the previous cohorts and what they did with the slides that we're about to see, they've actually expanded upon what are labeled sections 19.1, 19.2, and 19.3 here at the top right. So we'll actually get to see maybe perhaps more than what's on the ggplot book at the moment. Let's think about this broadly. The user-facing code that defines ggplot on the surface is not the same as the internal code that creates the ggplot under the hood. In this chapter, we'll learn about how the internal code operates and develop some intuition about thinking about the internals, starting with these two simple examples. Thinking about the order of the layers, we see that in this first code, we have this scale followed by the geometries. And in the second code, we have the scales kind of later after the first geometry. The point here is visually, for the most part, it's not changing much. But if you look really closely at the legends and how the dots and the lines are colored, there may be a difference there. Now, for another case, we have this LM smooth function, which I admit was actually kind of new to me. And I sort of regret doing this now because my students really would have appreciated this line of code a few weeks ago. This LM smooth function, in addition to recommending the linear models, is applying a formula. So for example, if we apply this to the ubiquitous empty cars dataset, miles per gallon on the horizontal, horsepower on the vertical, LM Smooth will now do what we expect it to do, which is draw the best fit linear regression line with the standard error confidence bars. But curiously, if we apply this LM Smooth to a slightly different situation, different variables, functionally, it'll do the same thing, but now this line of code is adaptable to which variables are introduced before it. So now what we're thinking about is ggplot has this capability where producing this slightly functional programming can work in the larger ggplot framework. Well, think in particular about the ggplot structure and plotting in general. The user-facing code and internal code is also separated by when they are evaluated. Using facing code like smooth that we looked at on the previous slide is evaluated immediately to give you a ggplot object, but the internal code is only evaluated when the ggplot object is printed or plotted. As we've seen before, when we have code like this, we could save it to a plot object. But in particular, what we're emphasizing is that at the moment, it does not plot the ggplot yet. Because in particular, the ggplot object is just a list right now. We could see that in the code as well. I've run this chapter's code. I have that object lowercase p saved here. And when we look at the internals this way, at least the structure of it, we could see that we have a list of lists that includes things like data, layers, and scales. In fact, this order that's presented here may be telling about what's coming up. So now, as you know, when you take that ggplot object and run it by itself or put it inside a print or plot statement, you get the plot to now appear. What I think I want to do is see if I could keep this graph on the screen for us. Moving on. Sorry, sometimes the graph stays on top of the window, sometimes they don't. There we go. So these are two separate processes, the creation of the list of lists and the printing process. Drawing the two processes into a bit of benchmarking to see how long they would take, we see that the creation of the ggplot object itself is not that expensive either time-wise or space-wise, but the printing of the object is a lot more expensive. So that is curious as well. What's going on is that the printing of the object is going through many, many steps. Perhaps it's easiest to think about it this way. Looking at the graph to the right, we see that there is a legend there for the drive variable. In your code, you know that you could show the legend on the right side by default, on the top, left, or bottom, or you could put legend position equals none to make the legend go away. Recall that the graph itself, will actually adjust where to put everything else compared to the legend. And that's also a hint that something deeper is going on here. In understanding these processes, this might sound strange. The plot that gets rendered from a ggplot object is actually a side effect of evaluating the ggplot object. First, we need to think about what is the ggplot object. We have this version of plot coming from the ggplot2 package as part of the dispatch of the object-oriented programming of it all. We have a fairly long function here. I'm not going to read the whole thing, but you'll notice elements such as data, ggtable, the viewport, the viewing window for you data visualization experts. But towards the end, what gets returned is the so-called invisible version of the output. That above code can be simplified more modularly as this data, ggtable, and then some work with grid. But to get the result to appear for some deeper advanced R knowledge, we return that invisible object, and hence the previous cohorts called this a side effect. Roughly put, you could start out as the ggplot object, which then gets passed to ggplot build, which in turn gets passed to ggtable, and finally to grid. It's probably easier to think about this in the tidyverse mentality with the pipes. We have our ggplot object, pass it to build, pass it to ggtable, and then finally pass it to grid. At each step, you get closer to the low-level information you need to draw for the actual plot. The remainder of this slide will think about the memory sizes of the objects. The ggplot object itself, as a baseline, was this size here. After the build step, you notice that the size is actually larger. After the ggtable, larger still. And then for the visual image, that could definitely be much larger, but depending on the format, dimensions, and resolution. We'll now go into the build and ggtable steps, but for the people here in the Zoom call, are there any questions or things to discuss right now?
No, I'm good. This is like, I guess this is useful if you're gonna be developing new functions or creating new geoms or something like that. I guess that's when these may come in handy, I suppose.
Yes,
But you understand, right?
Yes, I completely agree. My motivations for studying this chapter is I was considering trying to make my own version of ggRepel, and I need to know what's going on here. So now we'll go on to the build step. I think we'll have a different graph coming up here. Let's briefly look at the function body for ggplot build. Coming from the ggplot2 package. You'll notice layers, data, scales. A lot of time spent in layers and layout here. A lot of time spent in scales and layers here. And then finally, polishing up some of the data. The build step takes the ggplot object as input and transforms the user-provided data to a drawing-ready data, and maybe some other auxiliary metadata, like information about the layout. You can see that the drawing-ready data is built up incrementally, kind of like tidyverse pipes. These longer code chunks, admittedly, in my opinion, are a bit much to read in a first reading. But now taking that ggplot build and looking at a list, it's a long list. You'll notice that each entry in this list or nested list has a different step to it. As we move forward, this is what the ggtrace author is calling steps, like step 16, step 17. Whenever we plot a ggplot object, all these steps are followed through. Let's go ahead and have a particular toy example of a plot so that way we could think about how it's made step by step. The data from the ggplot is prepared in a special format for each layer. You could think of it as a data frame with predictable column names. A layer, specifically the output of the layer function of ggplot2, can provide data in one of three ways. Whether the data is inherited from what's supplied to the literal ggplot line of code, supplied directly to the layer's data argument. That's when you want to have a separate data frame going to only affecting one layer of your ggplot, or a function that returns data when applied to the global data. Let me go ahead and once again see if I could bring up the plot so we could see what's going on here. We're going to be thinking about this plot about the cars. Let me show it on screen for a few seconds. We have cylinders on the vertical, displacement on the horizontal, and we can see this is something of a scatter plot. Red and blue dots and some labels. The code itself is here on the left. We have some empty cars with those variables on X and Y. In this first layer, the geom point is only adding the color. It knows to get the X and Y coordinates from the aesthetics before. In the second layer, what we got for the red dots, what's going on here, to the best of my knowledge, is that empty cars is a relatively old data set, maybe about 50 years old. Our many other programmers wanted to talk about more recent cars. So MPG is a more recent data set, about 20 years old. However, we had to adjust that to get the data to align properly. So notice that the programmers took the displacement column of MPG and rescaled that to line up with what's inside empty cars. Nevertheless, this is creating the red dots and that's coming from a separate data frame. From there, the three labels, geom label, it's now getting the data from everything above, but adjusting to compute a group-wise statistic. So to say this part again, a layer could provide data in one of three ways. And moreover, the ggplot framework has to be able to handle this. Inside the layers element are layer objects, which hold information about each layer. So we're going to look at the layer objects 1, 2, and 3. The first one, the blue dots. The second one, the red dots. And the third one, the labels. If we go deeper and look at the layers, notice that each one has these class labels available to it. In particular, we have layer objects. They'll work well with the grammar graphics. And we get a preview that something called ggproto plays a role here. Each layer brings in layer data. The layered data, again, for the three layers presented in the plot. Well, first looking at the layer data function. Now, the first layer, the blue dots, the second layer that was brought in with a data argument to just that geom point layer for the red dots. And the third layer computed as group statistics for the labels. Now, this is where the data transformation journey begins inside the plot method. I mentioned earlier in a huge list that we have separate steps. That's what's being referred to here. We start to see that the framework is getting ready to address the layers and to set them up. After step 8 of about 40 steps, here's what we have so far. We notice that the ggplot framework is trying to create a layout based on facets, coordinates, and the layout layers that we've been talking about. The previous cohort wisely tried to dive in deeper here using some functions from the ggtrace package. At the time, a couple of elements of these codes did not work, and that might be my own ignorance. I tried to even bring in a couple of the R scripts that are in the ggtrace package. I installed the package with the most current version using remotes, but it didn't quite fix all the problems. So alas, we're not going to be able to go even deeper into studying the internals at the moment. Thinking about what ggplot has to do to make a layout. I mentioned before that the legend position could change things. We've also seen an example of facets, and think about how that would affect panels. Continuing with the book example, the data is augmented with the panel variable, spelled with all caps for some reason. And we have this coded up as computing the aesthetics. Then the group variable gets mapped, which you could think about as the analogous to dplyR's mutate. Of importance, especially to this book club, considering folks here spent a lot of time on this, are the scales. This is applied around step 13 of the process. This leaves the original data unchanged, but we may need to transform where the information is presented in the in the plot. For example, if you change one of the axes to a logarithmic scale, we should, if we had the ggtrace going, be able to see the changes that are being done. If you apply things like limiting the horizontal or vertical range, you have to worry about some of the original data now being out of bounds. So that's handled in step 17. That is, for example, if you put xlim 2 to 8, that may now have some data beyond 2 to 8. And ggplot still has to be able to handle that. For most of our purposes, we get that warning about missing values and so forth. We also have statistic transformations happening at step 18. These steps are in a very particular order because you had to handle the out of bounds and the scale transformations before that. In particular, if we have geom point and geom smooth, they have different definitions for their object-oriented notions of class. For geom point scatter plots, we have stat identity. For geom smooth, such as linear regression, we have stat smooth. Different methods are involved. After the scales, here in step 22, positions are adjusted, such as jittering, dodging, or stacking. If we gave the scatter plot a jitter, we would see that reflected here in step 22. Oddly enough, variables relevant for drawing each layer's geometry are not added until step 29. And then finally, we're reaching the output of the data after the build step. So notice that we have some sort of panel argument that could come in handy, or column, I should say. And I believe this is for oh, apologies. Yeah, this is still for this graph here. ggplot build also returns the trained layout of the plot, scales, panels, etc. in the layout element, as well as the ggplot object in the plot element. So what was that layout element? We have the original data, now the layouts, and then finally the plot element. Okay, once again, taking a pause here if folks in the book club want to ask questions or discuss something.
All good. No questions so far.
Now looking at the G-table step, we're going to come back to this graph here. So if you don't mind, I'll take a second to bring that back up. The return value of ggplot build contains computed data associated with each layer and layout ggproto object, which holds information about data other than the layers, including the scales, coordinate system, and facets, or more. We saw that in the output of the ggplot build, the elements were these three here. So the layout data included all of this. Which had these three classes respectively. The output of ggplot build is then passed to ggtable to be converted to graphical elements before being drawn. We once again have the plot function. And now let's think about rendering the panels. When we talk about the internals or more complex natures of ggplot, the slang is to think of a list of graphical objects, the slang being grubs for graphical objects. At step 6 of the building process, notice that we have something called geom grubs to create these graphical objects or to bring them into the fold. This step draws loops through each layer, taking the layer object L and the data associated with that layer, D, and using geom from the layer to draw the data. Oddly enough, this instance of ggtrace did work. So you'll notice that in the graph on the right, we have two facets. I believe that's what the 1 and 2 refer to. We have the scatter plot points. we also have the elements from the linear regression lines, the geom smooth. The geom grobs calculated at this step can also be accessed using the layer grob function on the ggplot object, which is similar to the layer data function. So we could get the graphical objects this way, which will get us the same thing as before. The scatter plots, dots, and the geom smooth lines. Once again, I believe I equals 1 and 2 are the facets. Each element of geom grobs is a list of graphical objects representing a layer's data in a facet. For example, this code here draws the data plotted by the first layer in the first facet. After this, the facet takes over and assembles the panels. Just to think about this broadly, remember part of what's going on with the faceted data and presentation is that in these two facets, it's actually creating two different graphs. So ggplot has to somehow organize its workflow that way. The graphical representation of each layer in each facet are combined with other non-data elements of the plot at this step, where the plot table variable is defined. For example, we start to bring in elements of a theme if you applied a theme to your ggplot. Plot table is a special graphical object called gtable, which is the same structure as a final form of the ggplot figure before it is sent off to the rendering. We will now look at plot table. It has a lot more of the internals we were probably expecting when we thought to take on this chapter to be able to tell where all the elements are going. Notice that these are graphical objects in addition to some of the statistical objects. Notice that there are also places for elements such as title. When it is first defined, it is only partially complete. It's only a partially complete representation of the plot. Uh, Based on the code that we just saw, the title, legends, and margins are still missing. And we would be able to look at that here. Recall that plot table is the output of layout render here in step 8. This is the load-bearing step that defines a bunch of smaller components internally. So briefly looking at the build function and the rendering aspect of it all, you'll notice that we start off first with some facets, then the panels, inside the panels, the coordinates. Now, with that said, plot table will start to bring things together with layouts, scales, themes, and so forth. Then the labels, such as title, subtitle, and caption. Then finally, bring it all back together. We could inspect these individual components. For those of you coming from a background of development, thinking about the object-oriented programming natures of it all, we would want to be very careful about the environment of all these graphical objects and variables. So that's now a render environment. For example, in the environment, the two facets that we see in the top right are represented by these graphical objects, or at least allocated this space. The individual panels include the geom smooth lines. And then once again, we have the plot table bringing together these graphical objects. The labels are brought in. So these are the numbers visually what we see as 2, 3, 4, 5, 6, 7. But also the displacement label. On the vertical, the number is 10, 20, 30, 40, and a place for the highway label. So this is where the previous cohorts really shined. It's so with all the emphasis of these steps in particular, they created an animation to finally think about this in the visual sense. What's being brought in at each step and how that's affecting the final displayed output. Let me once again take a pause here for the people in the book club. Any questions, discussion?
No, but that GIF is super cool. I love that they did that because you see visually exactly what you've been talking about of all the steps and exactly what is happening at each step. So that's genius. Yeah, super cool.
ولی دیالوگای قرمز مثلا پرپنچرین چرا خوب.
One of the motivations for having a chapter about the internals is to re-emphasize what you've learned earlier about guides. Let's think about the legend of a plot, legend box defined in step 11. That graphical object has to be allocated space visually in your viewing window. Then it undergoes some edits, tweaks, including resolving the legend position that we talked about earlier, the theme setting in the theme setting, and then gets added to the plot in step 15. While the bulk of work was done in step 11 was build guides function. That called guides train, guides generate graphical objects, which in turn called guide train and guides generate graphical objects for each scale, including positional aesthetics like X and Y. This is what previous cohorts wanted to emphasize. Why scales? The scale is actually what holds information about the guides. There are two sides of the same coin. The scale translates the underlying data to some defined space, and the guide reverses that, translates the space to data. One is for drawing, the other is for reading. This is also why the scale functions take a guide argument. Positional scales use guide axes as default, and non-positional scales use guide legend as default. So if I'm reading this correctly, for example, when you first start learning ggplot, you might want to quote unquote zoom in on a plot using X lim or Y lim to limit where your X values and Y values are going for what can be seen. However, once you know more about the internals, you kind of get a sense that you really should be putting those limits inside the guides of your scale because it works better with what's being processed in the G table steps. Guide legend itself has some object-oriented notions. And what I meant by putting the guides inside the scales here. This is the output of the guide train method defined for the guide legend. Most important piece of it is the key in which the data is associated with the legend. The output of guide train is passed to guide generate graphical object. This is the object of the guide gebgrab method defined for guide legend. All right, adding adornment. It's everything else after the legend step that we saw in the animations above. It looks trivial, but this step is glossing over about 150 lines of code. It's not that complicated. It's a bunch of low-level grid and G-table functions. At the time of this recording, this link is broken in that whatever referred to is now gone. All right, putting it all together, we took the ggplot object, ran it through the build function. Now pass that to the ggtable function. Now pass that into the grid, and we get the graph that we wanted. At this point, we probably should think a little bit about ggproto, that, as you mentioned, developers would want to have an understanding of this version of the object-oriented notions that ggproto is espousing. It's essentially a list of functions. Here we see, I'm just going to call it a string class with add, subtract, and show methods for strings. We also have a number class for add and subtract with the usual arithmetic. And then the show method reverts back to string. For example, adding these strings together, subtracting the E from June, or showing the words GG Book Club and putting the conjunction in between. Adding numbers, subtracting numbers, showing the numbers 1 and 2 and putting the conjunction in between. The ggproto syntax acts like a constructor in the object-oriented programming of it all. For example, if we define a person, allocate spaces for their first and last name and maybe a birthday, be able to combine the first and last name into a full name, and to calculate their age from their birthday. Putting that information into a description method. I mentioned earlier that the slides do a more thorough job of explaining sections 19.1, 19.2, and 19.3. For those interested in ggplot2, at this point, you would want to come back to the ggplot book itself and dive deeper into the object-oriented programming. But for fun, here are a couple instances of the ggplot2 objects based on the textbook authors, Thomas Lin Pedersen and Danielle Navarro, who are described here. There are notions such as subclasses as well, and a style guide for ggplot2. All right, thank you. That was an adventure.
Yeah, this was yeah, I think it's advanced. It's kind of like let's see, our advanced, the other book. I think I have it here actually. So I think this is like the advanced programming part of ggplot. It's always fun to see because there's always like a few bits and pieces that you sort of helps you understand ggplot a bit more, and then you read it again like next year or something, and then you understand a bit more. But it is, for me at least, is very high level things that I am not sure I understand 100%, but nevertheless, I do appreciate how they go through and explaining how this is not just like you put a ggplot and then a geom and then bam, it's there, right? Like there is a whole process behind it that we sort of like we can understand. So I appreciate that a little bit. So I'm glad they put that in the book. Not sure if they're going to keep it though for the next edition, but it's cool to have it. Yeah.
Yes, I completely agree. And even for more casual fans of this, the take-home message is really appreciating how much work scales it really did in the process and how much that affects the rest of the layout as well.
Yeah, I love ggplot, so I like learning these kinds of things. So yeah, it was good. Thank you, Derek, for guiding us through this very complicated chapter, but I think you were the right person to do this. So I am very thankful for that. And then yeah, so that's it. I think we can conclude this chapter. We have 3 more chapters to go through, and then we will be done with the book. So yeah.